today it is the law of sines. The law of sines. And to use the law of sines, you absolutely must know a pair of opposites, okay? So you need to know a side and its opposite angle. You have to have that. If you don't have a side and its opposite angle, you cannot do the law of sines, okay? Must be known, all right? If you have that, then the law of sines becomes pretty easy, all right? So let's look at example 1. So what I have is a pair of opposites. Okay, there they are. I have an angle, and I have its opposite side, which is 11. So I can use the law of sines. So I have angle G, which is a 68-degree angle, but I don't have its opposite side, and that's what I'm going to do. I'm going to set up opposites, 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 opposites. So what I want to solve for is little g, okay? So opposites, 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 opposites. So I go to my notes, and if I need to find a side, I'm just going to go opposite 1 over the sine of theta 1 equals opposite 2 over the sine of theta 2. So we're just going to set this up as little g over the sine of 68 equals 11 over the sine of 54. Okay? Super easy. In fact, it's the easiest one you use. Okay, it's called the law of sines. So it's g over the sine of its angle equals 11 over the sine of its angle. Okay, again, it's this side over the sine of its angle equals this side over the sine of its angle. Okay? That's all. And now all I'm going to do to solve this is we're going to cross multiply. So I'll multiply this sine of 68 up here. I'll multiply it up and I'll have little g is equal to 11 times the sine of 68 over the sine of 54. And I'm just going to use my calculator if I can find one. Maybe. So degree mode, right? Degree mode, quit. 11 times the sine of 68 divided by sine of 54, and I get an answer about 12.6. So little g is about 12.6. Okay, easy, isn't it? It's very easy. Okay, now, if I want to find the rest of this triangle, then probably from here the easiest thing to find is angle I. You guys agree? Angle I. So let's find angle I. So to find angle I, it's simply going to be 180 degrees minus my 54 plus my 68, because we know that there's 180 degrees in every triangle, right? So the two angles plus the third make 180. So I'm just going to go 180 minus the sum of those two angles. So I'll just take my calculator, 180 minus parentheses. Let's see, you guys can see it up there. My 54 plus my 68, and I'm going to get an answer of 58 degrees. Okay, that's 58 degrees. Okay, and I'm going to put that in there, put the 58 degrees in there, because I'm going to need that 58 degrees. I'm going to need that answer, and 12.6 here. Now, there is no Pythagorean theorem. There is no Pythagorean theorem. It is not a right triangle. Don't try and use Pythagorean theorem. It will not work. It is not a right triangle. But we have the law of sines, don't we? Right? We've got little I, so we have a pair of opposites, right? So let's set up the law of sines with little I. So I'll go little I over the sine of 58 equals 11 over the sine of 54. I'm going to cross multiply that up there, and little I is equal to 11 times the sine of 58 over the sine of 54, and then we've got everything we need. So I'm just going to use my calculator. 11 times the sine of 58 divided by the sine of 54, and I get about 11.53. Okay, so it's not a right triangle. So these formulas up here won't work. However, the law of sines is even easier. All you need is this pair of opposite side with an opposite angle, and you can use law of sines. Okay. Okay, example 2. Let's solve the next triangle. Okay, triangle CAT. Now again, if you have a pair of opposites, which we do, we have a pair of opposites. So you have an angle and its opposite side, you can use the law of sines. So if I look at this, I have the 15, but I need opposites, right? Think opposites, 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 so I can find angle C. Okay, we're just going to set up the opposites. Now, in my notes, to find the missing angle, we do the exact same formula, but we put the angles on top. It's just easier to solve that way, okay? It's the exact same formula. It's just easier to solve. If you put the unknown on top first, it's easier, okay? So, I'm going to go the sine of C over 15 equals the sine of 80 over 21, okay? So it's angle over side, sine of the angle of side. So it's the sine of the angle over its opposite side equals the sine of the angle over its opposite side. Really very easy, okay? Same thing, let's cross multiply. Bring up the 15. We're going to go sine of C equals 15 times the sine of 80 over 21, okay? So now, I'm just going to use my calculator. 15 times the sine of 80 divided by 21. But I get hold on, do it again. 15 sine of 80 divided by 21. But I get a decimal. Well, the decimal can't be the answer, right? Let me show you my calculator. It can't be the answer, 0.7. But we're looking for the angle. We're looking for the angle. What button do you push when you need the angle? So we need to do the sine inverse, right? We get, well, sine inverse of that answer. Use the answer button for accuracy. How about a 44.7? That seems more reasonable. So I'm going to go sine inverse of that answer, and I get an angle of about 44.7 degrees. Okay, so let's put that in there. 44.7 degrees. All right, now, angle A. Angle A is easy, right? Angle A, we just know there's 180 degrees in a triangle, right? So to get angle A, let's get angle A from adding them together. Add those together. Subtract from 180, right? So for angle A, we're going to make it 180 minus my 44.7 plus my 80, right? Just use my calculator. 180 minus parentheses 44.7 plus my 80. And I answer about 55.3. Okay, let me put that in there, okay? So my 55.3, okay? Now I need to find little a. Am I going too fast? Am I okay? Okay, I got to find little a, and there is no Pythagorean theorem. I'll say it again. There is no Pythagorean's theorem. It's not a right triangle. So how am I going to find little a? Yeah, let's set up the opposites again, right? Set up the opposites. So I can still set up 21 over the sine of 80 would equal little a over the sine of 55.3. So set up your opposite. Again, we're going to use the law of sines. So I'm going to go, all right, I'll squeeze it in over here. I'm going to go little a over the sine of 55.3 equals 21 over the sine of 80. Okay, so think about what I did. Again, I'm going side over the sine of its angle equals side over the sine of its angle. It's a really pretty easy formula. Yeah, I'm going to cross multiply this up here, and then I'll have 21 times the sine of 55.3 divided by sine of 80, and we'll go clear. We'll do 21 times the sine 5.3 divided by sine of 80. I can answer about 17.53. It's easy, isn't it? It's easy. It just deals with opposites. It's easier than that, isn't it? All you got to do is find your opposite, set it up, okay? Now some kids, here you want to hear a little hint, will stop using that. Because the law of sines will do that for you, because the opposite angle is always a 90-degree angle, okay? So if you hate that, you could probably use this law of sines to do the right triangles as well, because it's a 90-degree angle, okay? Now, should we turn the page? Easy? All right, here we go. So, example number 3. So, here we go. Okay, a bird is perched on top of a pole, and an observer located at the base of a steep hill 110 meters downhill from the base of the pole. The angle of inclination of the hill is 50 degrees. Okay, so that's 50 degrees right there, right? And from the hill to the pole is 8 degrees, so that's 8 degrees right there, okay? So find the distance from the bird to the observer. Okay, so let's see what we know, okay? Let's see if we can find out anything. Well, we always need at least 3 things. You always, by the way, 3 things, you have to have 3 things to do it. So I don't have 3, I got the 8, I got the 110. I don't have enough information here, right? But what I'm going to do is I'm going to create, yes, totally right. I'm going to create another triangle. You guys see my triangle right there in yellow? So that's a 90, right? That's 50 degrees, right? So that'd make that 40 degrees, right?
Make it 30. Oh wait, no, yeah, you're right.
And then that'd make that 140 degrees. Am I getting somewhere? So now I might be able to take a look at this triangle with 140. Alright, let's see if I've got a pair of opposites. Well, let's see. 110. Oh, I need one more angle, right? I need this angle up here. Could I find that angle up there? 180 minus 140 plus 8, right? We'll give you that angle up there. 180 minus 148. 32. So this angle up here is 32 degrees. Put it there, 32. How's that? Squeeze in 32. So now, do I have a pair of opposites? Well, if I want to find the pole, just call it P for pole, how's that? I've got a pair of opposites here, and I have a pair of opposites here, don't I? See my opposites, opposites. So I've got my 110 and the 32. I'll find the pole with the 8. So I'll set it up. I'll go the P over the sine of 8 is equal to 110 over the sine of 32. Okay, so now I've got my opposites, but I had to draw, like Lane said, I need to draw another triangle, which I did. And then I used the other triangle to go ahead and locate the 140, which gave me the 32. Okay, now it's easy, right? Multiply up the 8, sine of 8, so P is equal to 110 times the sine of 8 over the sine of 32, and I'm just going to use my calculator to do that. 110 times the sine of 8 divided by the sine of 32, and I get an answer about 28.9, or pretty close to 29 feet. If I round it up to 29 feet, P is approximately 29 feet. How's that? Okay, so we got lots and lots and lots of time to get the homework done, okay? Please draw the triangle, show the work. 1, 2, 3, 4, 5 problems. That's it, okay? Easy.